All right, let's get right into it. When I say the word robot, what pops into your head? For a lot of us, it's something straight out of a movie, right? These super complex machines that look, act, and maybe even think just like we do. But what is a robot really? Today, we're going to pull back the curtain and separate the sci-fi from the reality. So seriously, what do you see? Is it some kind of friendly metal butler, a futuristic soldier, maybe an intelligent sidekick? Look, pop culture has handed us this really powerful, really specific blueprint for what a robot should be. The big question is, how close is that vision to what's actually happening today? Okay, so first up, let's talk about the robots we all imagine. You know, that sci-fi vision, this all-purpose humanoid machine that can do anything. It's an awesome dream, for sure. But here's the twist. The biggest hurdle isn't building the body, it's building the brain. And that right there brings us to our first major reality check. Let's call it AI's common sense problem. See, before a robot can act like a person, it has to be able to understand the world like one. And, well, it turns out that's the single hardest part of the entire puzzle. You know, this quote from cognitive scientist Peter Gardenforce just hits the nail on the head. He points out that an advanced AI, with all of its incredible processing power, is actually outmatched in some really fundamental ways by a human toddler. We're not talking about doing complex math here. This is about having a basic gut-level grasp of how the world actually works. Let's actually break that down. A little kid gets causal thinking, right? If you push a tower of blocks, it's going to fall over. Simple. But in AI, it's an amazing pattern matching machine, but it doesn't inherently get that A causes B relationship. And a toddler can read social cues. They know the difference between a wave hello and someone just, I don't know, swatting a fly. Plus, they learn through what's called embodied cognition. They learn by touching things, by falling down, by physically interacting with the world. AI systems, they just don't have that physical trial and error experience to ground them in reality. So if robots aren't these sentient, thinking beings we see in the movies, then what are they? What does the real robotic workforce actually look like? The sheer scale of it, well, it just might surprise you. Get this. According to the International Federation of Robotics, by the end of 2023, there were roughly 4.3 million industrial robots working around the globe. This isn't some niche futuristic tech. This is the backbone of global industry right now. But hold on, where are all these millions of robots? Well, they're not walking our dogs or making us coffee. The vast majority are tucked away in highly structured manufacturing plants. Think automotive, electronics, and metal industries. They are the big ones. These are places where robots do jobs that need insane precision and repetition, 24/7. And this is the real face of the modern robot workforce. It's not a humanoid. It's a hyper-specialized industrial arm. It doesn't need common sense to do its job. It just needs to do one specific thing, like welding a car door or placing a tiny microchip millions of times, perfectly. So yeah, it's less of a thinking machine and way more of an incredibly sophisticated tool. Okay, so we've got these incredibly good, super specialized robots, but as we start moving them into more dynamic environments, where they're working alongside actual people, a whole new challenge pops up. It's not enough for a robot to be good at what it does anymore. The next level is for it to know when it's about to mess up. And this is where some really fascinating new research comes into play, with methods like assumption alignment tracking, or AAT for short. Now, put simply, you can think of AAT as a way to give robots a kind of self-awareness. It's designed to let a robot constantly ask itself a critical question. Hey, are the conditions around me actually right for me to succeed at this task? The whole process is actually pretty elegant. First, the robot checks its own programming assumptions against what's happening in the real world. So it might think, my program assumes my camera lens is clear. Is it? Or, I'm assuming the floor isn't slippery. Is that still true? Then it takes those real-time checks and combines them with data from its past experiences to predict how well it's probably going to do. It's literally learning to connect the dots between a potential problem and an actual failure. And this kind of self-assessment is absolutely critical. We can see it in action here. In one study, researchers found a direct link. The more a robot's basic assumptions were wrong, say a sensor was getting a lot of fuzzy data, the longer it took to complete its navigation task. By tracking these issues, the robot could actually learn to predict, hey, I'm probably not going to do this well, and could even ask for help before it completely failed. All right, so let's pull back and look at the bigger picture here. I mean, creating robots that are really good at their jobs and even self-aware is one thing. But the ultimate goal, the real holy grail, it's getting them to work effectively and, most importantly, safely, right alongside us.
Now, this is a massive field of study, but a lot of it boils down to some really fundamental human challenges. Like, how does a robot clearly communicate what it's about to do? How can it possibly understand our gestures or just, respect our personal space? And maybe the biggest one of all, how do we design a system that builds the right amount of trust? You don't want too little, but you definitely don't want too much either.
And when we look at the top trends in robotics today, you can see these exact challenges being tackled head on. AI and machine learning are making robots smarter, more adaptable. The huge rise of cobots, or collaborative robots, is all about designing machines specifically to work safely in shared human spaces. And yeah, look at that. Even humanoids are on the list, which just goes to show that the dream of a robot that can navigate our world is still a really powerful force driving all this innovation. So, when you think about it, maybe the goal was never to perfectly copy ourselves in metal. Maybe the real robot revolution isn't about replacing people, but about augmenting them. The true challenge seems to be building tools that take on the dull, the dangerous, and the difficult jobs, freeing us up to be more creative, more strategic, and, yeah, ultimately more human. And that leaves us with one last big question to chew on. What kind of work is that, really?